Hey folks, I had a question coming out of section 7.3, number 33, and I've got these nonlinear systems of equations. And if I wanted to solve them, if I look at this, there's really a couple of ways I could do this. That is supposed to be a rectangle. That bombed. Let me redo this. If I look at this system of equations, I'm just not able to draw that well in my note-taking app today. I really wanted a rectangle. Oh, there we go. There's a couple of things I could do. The way I did it, and I can see my answers worked out, is I used substitution, meaning I happened to solve this, oops, not that one, let me move this over, this particular equation for y squared, right, by moving the x minus 1 squared to the right side of the equation and then subbing it in here. And that's one way I could do it. Or I actually, just as I'm noticing making this screencast, I noticed that if I just added these equations together, the y squares would eliminate. So that's yet another way to do it that I just didn't notice until right now. So once I solve, and let me highlight this so we can see it, once I get this and plug it in here, that catches you up to this part of my solution. All right, so then I need to PEMDAS, right? So I need to make sure I square, I need to square this binomial, right? And that's what you see here, x squared minus 2x plus 1, and then I need to distribute that negative to those three terms in that now trinomial, right? And that's where you see minus x squared plus 2x minus 1. But then these ones also cancel. That's what you're seeing in the next line. And then after those ones cancel, I got to distribute this negative again, right? So there's a bunch of PEMDAS to do, which is great. We just got to take care of it. And then when I'm at this line, I can see I have a quadratic equation. So I either need to set it to 0 and use the quadratic formula or set it to 0 and factor. So when I moved that 12 over and combined these like terms, here's my quadratic equation, and I can see a GCF of 2. So I factored that out. You can see that right here. And then I was able to factor that trinomial, 2x squared minus x minus 6, into two binomials, right? I had x minus 2, 2x plus 3, set each of those to 0, and as I scroll down, these are my two x coordinates. And then what I'm going to do is I'm going to take that and I'm going to plug each of those x values back into my y squared equation and ultimately solve for y squared. So as I plug those back in, let me scroll down so you can see this, and I'll just change highlighter colors. Here I am plugging into that y squared equation. The first one I did was 2, right? I let x equal 2, the first of my solutions. All right, 2 minus 1 is 1, 1 squared is 1, and then I had 1 minus 1, so I got 0. So if y squared was equal to 0 and I square root both sides, y is going to be plus or minus 0, but 0 is neither positive nor negative, so I just get y equaling 0. So when I started with 2 for x, I got 0 back for y. Then I tried that again with negative, I circled all of it, with just negative 3/2. I'm going to plug that back in here and see what y squared is equal to. So that's the work you see me doing here. All right, negative 3/2 minus 1, just so you can see all this math play out. Negative 3/2 minus 1, this is going to be 1 minus, this is going to be negative 5/2 squared. Right, this is going to be 1 minus, okay, negative 5/2 squared is like saying 25/4, and I need common denominators, so this is 4/4 minus 25/4, which is ultimately going to be negative 21/4, which is great. Y squared is negative 21/4, and I'll square root both sides, but this doesn't have a real solution, right? We can't take an even index to a negative radicand, so I get no y values from there. So ultimately, my only ordered pair is 2, 0. Okay, thanks so much. Bye.